One, two, three. Today we're looking at upwelling, downwelling, El Nino, and La Nina. Surface currents also play a role in the vertical up and down movements of deeper water, mixing the upper water column. Upwelling is a process that brings deep water to the surface. It's extremely important in that it brings nutrient-rich deep water to the nutrient-deprived surface, stimulating photosynthetic organisms and increasing biodiversity. Upwelling occurs where surface currents are diverging. Pause. Global upwelling occurs where surface currents are diverging or moving away from each other. As the surface of water move away from each other, look at the arrows, deeper water must be brought into the surface to replace it, creating an upwelling zone. The green and blue zones in the middle of the arrows are the upwelling. In the equatorial Pacific, the trade winds blow the north and south equatorial currents towards the west, while Ekman transport causes the upper layers to move to the north and south in their respective hemispheres. This creates a divergence zone and a region of upwelling and high productivity. A similar process occurs near the Antarctic continent, creating one of the most productive regions on Earth, the Antarctic divergence. In this case, west wind drift, the Antarctic circumpolar current, is flowing parallel to, but in the opposite direction of the west wind drift, represented by the arrows. When both currents occur in the southern hemisphere, Ekman transport will be to the left, so the eastward flowing west wind drift water will be transported to the north, and the westward flowing east wind drift water will be transported to the south, creating a highly productive divergence zone in the middle. The effect of seasonal variations in upwelling can also be seen in the Arabian Sea. During the Indian monsoon, July through September, a southwesterly wind blows through the Arabian Sea, causing coastal upwelling south of the Arabian Peninsula. In winter and spring, upwelling is suppressed by prevailing easterly wind. Pause. The effect of seasonal variations in upwelling can also be seen in the Arabian Sea. During the Indian monsoon, July through September, a southwesterly wind blows through the Arabian Sea, causing upwelling in the south of the Arabian Peninsula, where it's circled. In the winter and spring, an upwelling is suppressed by a prevailing easterly wind. Pause. The effects of seasonal variations in upwelling can also be seen in the Arabian Sea. During the Indian monsoon, January through September, a southwesterly wind blows through the Arabian Sea, causing upwelling south of the Arabian Peninsula. It's all the red there. In the winter and spring, the upwelling is suppressed by a prevailing easterly wind. Notice in the right-hand side that there is much less red, yellows, and oranges. The upwelled water is cold and rich in nutrients, leading to high productivity. Many of the most productive regions on Earth are found in upwelling zones. Coastal downwelling is where surface water is forced downwards, where it may deliver oxygen to deeper water. Downwelling leads to reduced productivity as it extends the depth of the nutrient-limited layer. Downwelling occurs where surface currents come together. The converging water has no place to go but down, so the surface water sinks. Since the surface water is usually low in nutrients, downwelling leads to low productivity zones. An example of a downwelling region is off the Labrador coast in Canada, where the Gulf Stream, the Labrador, and the East Greenland currents converge. So, summary of upwelling and downwelling. First, coastal upwelling has wind that is parallel to the coast and brings up nutrient-rich water, leading to great fishing off the coast of California and Peru. Coastal downwelling has wind that runs perpendicular to the coast, pushing warm water to the coast and downward, bringing some oxygen to the lower water. Surface currents cause upwelling globally, where they diverge or move apart, bringing cool, nutrient-rich water to the surface. Surface currents cause downwelling, where they converge or come together, causing warm, oxygen-rich water to move downward. As we saw previously, coastal upwelling off of Peru makes that region one of the world's most productive fishing grounds. But ever so often, the conditions in the region are very different. Every few years, the cold, nutrient-rich water is replaced by unusually warm water that is low in nutrients, leading to a decline. Pause. As we saw previously, coastal upwelling off of the coast of Peru makes that region one of the most productive fishing grounds, but every so often the conditions in the region are different. Every few years, pause. As we saw in the previous coastal upwelling off the coast of Peru, pause. As we saw previously, coastal upwelling off of Peru makes that region one of the world's most productive fishing grounds. But every so often, the conditions in the region are very different. Every few years, the cold, nutrient-rich water is replaced by unusually warm water that is low in nutrients, leading to a decline in fish populations. In addition, the normally dry areas receive lots of rain. Because this phenomenon occurs on the northern winter close to Christmas, it is called El Nino, the child. More formally, the event is referred to as El Nino Southern Oscillation, ENSO, E-N-S-O. While the exact reasons for the switch in water temperature isn't clear, it's much easier to explain how they lead to an El Nino. Under normal conditions in the equatorial Pacific near Peru, the trade winds, easterlies, blow towards the west, moving large amounts of warm surface water towards the western Pacific around Southeast Asia. As the surface water moves west, it is replaced by cold, nutrient-rich deep water through upwelling. The coastal upwelling leads to a shallow thermocline in the eastern Pacific. There is a low pressure over the western Pacific, leading to rising moist air and a significant amount of precipitation in the region. In the eastern Pacific, near South America, there is a high pressure, leading to drier conditions. El Nino events occur roughly every 2 to 7 years. During an El Nino Southern Oscillation, also called the ENSO, the high-pressure system over the eastern Pacific diminishes. So the trade winds are weakened, or in extreme case will even reverse. When this happens, warm surface area begins to flow east across the Pacific towards South America, warming the South American coast. Pause. El Nino events occur roughly every 2 to 7 years. During an El Nino Southern Oscillation, also called ENSO, the high-pressure system over the eastern Pacific diminishes. So the trade winds are weakened, or in extreme cases will even reverse. When this happens, warm water begins to flow east across the Pacific towards South America, warming the coastal South American water by up to 8 degrees centigrade Celsius in strong ENSO years. This high flow of low-density water deepens the thermocline and prevents upwelling, which dramatically reduces productivity and can devastate populations of fish and other marine life. In the atmosphere, the low-pressure system in the Pacific is replaced by a high pressure, bringing dry or even drought conditions to Southeast Asia and Australia. The low-pressure system moves east across the Pacific, potentially reaching as far as South America in strong El Nino years. The low pressure over the eastern Pacific brings lots of rain and flooding to South America. El Nino affects our weather even though we were nowhere near where it's occurring. The warmer water causes the Pacific jet stream to strengthen and split off of the coast of California. This causes an unfavorable wind coming off the East Coast, making tropical storm activity in the Caribbean and Gulf much less likely. However, it decreases the activity in the lower Pacific due to the exceptionally warm water. The most notable impacts from El Nino in the United States occur during the winter. Typically, El Nino tends to peak during the winter months. Oftentimes, this occurs in November and December, but it can peak a little bit later than that. During a typical El Nino, the storm track will shift farther south, bringing more opportunities for rain and storms to California and the southwestern United States. The southeastern U.S. also tends to be stormier during El Nino winter because of the split jet stream, which brings more tropical moisture across the southern United States. An El Nino winter in the northeast is often warmer, but the region can still be stormy with frequent snowstorms. The intensity of El Nino can also vary in scale, as some can be stronger or weaker than others. Southeast Asia will experience drought. Many crops that depend on monsoon season will die. Fishing off the coast slows as the warm water is not mixing with the cool water. Because of the southern oscillation is a cyclic pause. Because the southern oscillation is a cyclic pattern, the eastern Pacific is not subject just to unusually warm conditions. There are also periods of abnormally cold water in the region known as La Nina events. During a La Nina, the trade winds are unusually strong, leading to increased upwelling and transport of deep cold water to the surface, strengthening monsoons in Southeast Asia and increasing droughts along the South American coast. Pause. Because the southern oscillation is a cyclic pattern, the eastern Pacific is not subject just to unusually warm conditions. There are also periods of abnormally cold water in the region, known as La Nina events. During a La Nina, the trade winds are unusually strong, leading to increased upwelling and transport of deep cold water to the surface. There's strengthening of monsoons in Southeast Asia and increasing droughts along the South American coasts. Notice that in La Nina, the upper illustration, the cold water is much more pronounced than in a normal year, moving cold, nutrient-rich waters further into the Pacific Ocean. La Nina brings us more pause. La Nina brings us warmer than normal weather in the winter. The Northwest is extremely wet and cold. The South is very dry. Tropical cyclones will occur more in the Caribbean and Gulf of Mexico, but fewer storms will appear in the Northern Hemisphere Pacific. Southeast Asia's monsoon season Pause. La Nina brings us warmer than normal weather in the winter. The Northwest is extremely wet and cold. The South is very dry. Tropical cyclones occur more often in the Caribbean and Gulf of Mexico, but fewer storms in the Northern Hemisphere Pacific. Southeast Asia's monsoon season increases in severity and often causes catastrophic flooding. El Nino and La Nina events alternate, although the presence of one does not always mean the other will automatically follow. El Ninos occur roughly every 2 to 7 years, and each event may last from a few months to a year or more. Although we do not understand exactly why or when ENSO events will occur, We can anticipate their arrival by monitoring a number of ocean and atmospheric conditions that make up the multivariate ENSO index, MEI, which we're going to be using in an activity today. Examinations of the MEI over time demonstrates the cyclic nature of ENSO events. Positive red values indicate warmer than normal conditions, El Nino, while negative blue values represent conditions that are cooler than average, La Nina. The greater the deviation from zero, the stronger the event. Notice that the intense El Ninos are in 1983, 1997 to 98, and 2015.